So, we're talking about digitalization. I would like to share with you what you're probably not too much surprised about is that digitalization changes everything and has the power to disrupt both our personal lives as we experience it today, probably each and every day, as well as our business lives. And you see a couple of statements here that are quite important in that regard. First of all, digitalization presents an enormous business opportunity. A lot of dollars, a lot of business is going to be made in the next years to come with digitalization and with the ones who are going to embrace digitalization as an opportunity. On the other side, a citation by Pierre Monterme, CEO of Accenture, it is the fact or the main reason for just over half of the companies on the Fortune 500 that has disappeared in 2000 that they did not embrace digitalization and they did not adapt to this new circumstances and the opportunities. And it's something that can turn whole states and countries and change them. As you can see that this is being seen as a strong opportunity, rightly so, for the industrialization strategy of Dubai in terms of transforming the UAE into a global platform for innovative industries. Tells you about the importance, tells you about the disruptiveness of digitalization from a business perspective. But let's have a look at business models, how they changed our private lives. The old bookstore is gone, now we download our books digitally. The old record store is gone, now we stream the music. The old telephone book you don't find at your homes anymore, you go into the internet and look it up. And even asset-rich industries like taxi driving, where you had millions of cars around the planet, is changing because now Uber is putting a new digitalized platform in place and is just replacing all these cars by individual cars that are driving around today. Tells you about the disruptiveness of businesses that used to think they are safe. Digitalization is not a topic that anyone does in the industrial environment because it's nice. It's something that's called digital and it's state of the art and the voice of the day. It is because there are strict business necessities around this. And the first one is speed. You need, as a company, to get your products quicker out there into the market. And the one who has their products out the soonest is the one who grabs market share and who's the most competitive one. The second topic is flexibility. We see more and more in industry manufacturing of a lot size of one coming. If you see modern luxury cars, they're being built in around about 1 million different configurations. So there's hardly any car that's being built a second time. Or even sneakers, which is a classical product which used to be a mass product in the past. Going forward, you go to the internet, you order your own sneaker with your own device according to your own physical properties, you get it manufactured within a couple of days and you get it sent, and this is true lot size of one because everyone has own feet and an own taste. Nobody wants to compromise on quality, even under the circumstances of flexibility and lot size of one that I've been talking about. This is mandatory and has to be maintained in the industrial environment. And last but not least, efficiency. Efficiency in terms of using assets, in terms of using energy, and in terms of cost, because you want to be competitive in your business and make sure that you have the lowest cost basis of anyone out there in the market in order to make sure that you're ahead of competition. Whenever it's about digitalization of industries and of companies, of course, security is a major topic. The last thing you want is that you're fully digitalized and there is a disruption in the manufacturing process because someone just intruded and caused the system to be disrupted. So in order to meet all these four requirements, speed, flexibility, quality, efficiency, it's about digitalizing the whole value chain of a company. And there are 5 steps that need to be digitalized. The first one is the product design and simulation. The second step is the production design and simulation. The third one is then production engineering. The fourth one, the production as such. And the fifth one is looking at the life cycle of the product is the service part. Servicing the product as such that has been generated, and secondly, servicing the production line. In order to do this, we need to first of all connect all these 5 steps, regardless of where they are in a company, and from a localization perspective. Sometimes, for example, a car is being produced by a huge number of departments within a company, and it's being a worldwide setup. This needs to be put together and ring-fenced in order to have the same kind of information available everywhere and the same kind of processes everywhere. And that's being done through a collaboration platform that in the Siemens case is called Teamcenter. And this collaboration platform provides all sets of data regarding product and production to everyone in the company, and that worldwide, including suppliers and logistics. And then right at the end, in the service part, whenever the product was manufactured or is being manufactured, you can take data out of the product and out of the production, feed them into a cloud-based operating system, analyze them, and then use them to enhance both the product and the production. How do we digitalize now the whole value stream out of these 5 steps? We digitalize it by creating a digital twin of each of these steps. And in the first step, we create a digital twin of the product. We simulate the product, then using this digital twin, improve the design again, simulate again, and improve and simulate until we have the digital twin of the product available. Then the second step, we need to think how we are going to build this product. So we need to design the production and then simulate production. Design again and simulate and design again and improve until we are happy with the design of the production. In the next step, we need to tell this digital twin of the production and the product how it's being manufactured. So that's what we call production engineering. It goes down into reality now, and we need to make sure that the PLC code and the automation code for the production line is being generated. And we do this automatically in a full-blown process that happens all along in the digital world. Then we also digitally do the production execution before we build something up in the real world. And in the last step, through services, we take the data out of the product and of the production in order to make sure that we improve the production continuously as much as the product. And only after the product design has been done, I build a prototype of the product. After the digital twin of the production is there, I actually build the production line in the real world until I'm really sure what I'm going to invest for. And only once I've been doing production engineering and production execution in the digital world, I transfer it to the real world and I do the production in the real world. So I do the whole process using the digital twin in the digital world and then transfer it into the real world. So at the end of this process, we have a digital twin of the product, we have a digital twin of the production process, and we have a digital twin of the equipment that I have in the shop floor that is supposed to then afterwards manufacture the product. And we bring all of these together within Teamcenter, our collaboration platform, to make this information available to everyone in the company. And we can also incorporate then suppliers. And if, for example, one part is being produced in the UAE and it needs to be part of an airplane that's being manufactured somewhere in Europe or in the United States, this is the way how to collaborate worldwide from a design and manufacturing perspective. And this is how the worlds are being connected. Let's have a look at an example of a product that's being designed and manufactured through this process. In the first step, before anyone touches this product, a requirement spec is being built. And in this case, we have a small PC, an industrial PC, which is called Nanobox, which is being manufactured in our Siemens factory in Hamburg. Before anyone starts doing something on the design, a requirement spec is being put together. That tells you how big this device should be, what the ambient temperature should be, what the calculation power of this whole device should be, what kind of connectivity, what I need. So everything is included in this requirement spec. And this requirement spec is being fed into the collaboration platform that I talked about, which is Teamcenter. Now the designer starts designing this product with a CAD tool that takes this requirement spec out of Teamcenter, and it's being built in the CAD tool, which then ends up and results in a digital twin of this PC. You can see it can be assembled and disassembled in the virtual world, and once I've been doing this, I can feed this into the simulation tool. And in this case, we're simulating how the airflow in this product will look like in order to meet the specifications for the ambient temperature. If that doesn't work, then I go back to the drawing board and I design the product again, and I simulate and I design until I'm happy with the digital twin of this product. In the next step, the question is, how do I build this product? How much capacity do I need? how do the workspaces and the assembly cells actually look like in order to assemble this product. And you can see in this case, the lady is assembling this nano box and is checking whether the screw can be tied manually in the right way and the ergonomics of this workspace are adequate. But we can also simulate whole factory environments, all right? In this case, so that consists of more than one workplace, we can simulate automation, we can simulate capacity shortages, we can simulate buffer spaces, so everything that we require in terms of laying out a whole factory environment for a certain demand of these nano PCs. And if there's not sufficient capacity available, you invest, but you're sure via the simulation that what you're heading for and what you're looking for actually makes economic sense. Now, at the end of this process, we have a digital twin of the product and of the production. As you can see with the moving box from the top left to the bottom right, now we automatically generate the PLC code for the assembly line using the digital twin of the product and the digital twin of the production. In the past, this was a very tedious and long-lasting process because the code had to be manually built. Now we can do it automatically and save between 30 to 40% of the engineering cost and engineering time in order to get the lines up and ready. Now there's other parts of this chain that need to be also engineered, but in the next step, this PLC code needs to be verified. It needs to be improved and needs to be debugged and needs to be optimized in order to make sure that the operations and the manufacturing part works as quickly as possible. And in order to do this, we take the digital twin of our automation system. That's what you're seeing at the bottom right, corresponding to the digital twin of the manufacturing line. And this actually controls each other. If the PLC code is not right, the robot would be doing funny things. This we use to debug our code. This we use in order to optimize our manufacturing process and make very sure that the whole line together with all the programming code actually works before I start in the physical world to produce anything. Now, we can also at the same time then engineer with the TIA portal in a holistic engineering environment, IOs, HMI, and whatever the case might be in order to have a complete manufacturing line. So once the whole production is engineered, we move into the real world. We send the bill of material from the digital twin of the product and the production into our MES system and then down into the automation facility and part of the manufacturing plant and then produce the actual product with all our automation systems and drives that we have. So now the product is done, and now it's in real life. And most of the products today are connected to the Internet of Things. The production line is connected to the Internet of Things. Cars, for example, are connected to the Internet of Things, and they're sending out a lot of data. And this data can be captured, can be stored in the cloud, and then can be analyzed using applications that are specific to the product and the production in order to optimize the production itself, if there are any deficiencies in the production processes or any leeways to optimize it and to make it shorter and more efficient. And on the other side, we can also use this data to improve the product because of wear and tear. Or we see with regarding a car that certain parts fail more often than others. So all of this can be used and analyzed to such an extent that we improve the product as such as well. This is being done, the last step, in the Siemens case by using an Iot Operating System, that's how we call it, called MindSphere. And this operating system can of course be used in the industrial environment, looking at production, looking at products, optimizing production and products in what we call closed loop manufacturing. But we can use this operating system as well to connect totally different devices that you can see at the bottom left side. Industrial plants, automation systems, robots, we can connect trains, we can connect laptops, we can connect cranes. So whatever is out there, elevators, whatever is out there and can connect to the Internet of Things, It's being connected through a layer that we call Mind Connect. And then we have a layer that we call MindSphere, where all the data that are coming out of these products are being stored and made available then for applications that are product and industry specific and analyze the data and give advice how to operate and improve them. And these applications can come from all kinds of different parties. There could be Siemens applications. There could be applications that would be coming from third parties, so the crowd of developers, right like you see it on your iPhone, and it could be companies that produce products like, for example, cranes or trains or whatever the case might be. So a very, very powerful tool to digitalize any kind of industry in the Internet of Things. So that's the platform, that's the operating system we are introducing here for the first time in the UAE at GMIS. And I can tell you we have a huge level of interest there. We have by far more than 100 customers already there, connected companies that connect their machines to MindSphere. And the number is growing almost by the day. This is the portfolio, how we support the digital enterprise as a concept. From a product lifecycle management software perspective that's in the design center for products and for production. On the right-hand side, totally integrated automation. That's our portfolio for automating all kinds of manufacturing environments on the shop floor. And in between, the manufacturing operations management that builds the bridge between product lifecycle management and the automation part. The basis of it is our collaboration platform, Teamcenter. And at the top, MindSphere, taking the data out of the shop floor and out of the products and bringing them back into the design center where product and production is getting optimized. You might ask yourself, is this pie in the sky what I'm talking about, or is this something where we see real cases out there in the world already, and what is the benefit for the manufacturing companies using these tools? And one of the shining examples here is an Italian car manufacturer called Maserati that you probably all know very well. And Maserati is moving into the volume car business with a new car called Maserati Ghibli. And as you can see there at the bottom, they're using all kinds of products from Siemens in order to design the cars, design the production, and manufacture the cars. And the result of it is that with the Maserati Ghibli, they brought their development time down from 30 months for a car to 16 months. They're delivering the car in 70,000 different configurations. That's the complexity and the flexibility that's being required. And they get 3 times more cars out of the same floor space than ever before. And let's have a quick look at this example from a customer's perspective.
I think first and foremost with the Ghibli we wanted to produce a new Maserati, meaning that the Ghibli adheres to the core brand values of Maserati, being Italian style, dynamic performance and refined luxury. The challenge obviously in terms of launching higher volume cars within a modern manufacturing facility, state-of-the-art manufacturing facility, is to retain that bespoke feeling within the cars, which is very much appreciated by our clients.
Being able to work in a digital twin is a significant evolution compared with the past. By using integrated software such as NX and Teamcenter, we can have an interface of all the teams developing the project on the same mathematical base. This allows us to reduce analysis times and to avoid possible errors caused by miscommunication between the different teams.
We can say that one of the strong points of Siemens is the fact that we offer a product portfolio which covers both the manufacturing and the engineering side. And what's more, that these products are also tightly integrated.
L'impatto degli strumenti Technomatics.
The Technomatics tools are above all useful in the analysis of the product and in the simulation of the product line. Earlier planning and development know-how is thereby incorporated and implemented in the overall design.
Utilizzare le esperienze del plant nel design della linea.
The aim was to produce 3 times as many cars than before, while maintaining the same level of quality, which is obviously higher simply because it is a Maserati.
Well, CAS is an integrated system used by the entire Fiat Chrysler Automobiles Group and is also installed in the Maserati plant. It facilitates the management of the plant with Siemens, PLC and HMI hardware with WinCC and Step 7, delivering all the diagnostics of everything that happens in the plant in real time. So Siemens technology helps us to be more efficient and have better quality management in the production plant.
The expertise is not only in the tool, so not only in the software, but above all about how to use the software within the setting of Maserati and FCA, because that is where we really make the difference.
So that's a real implementation of a digital enterprise. But there's also great examples here in the UAE, and there's a great collaboration between Siemens, Strata and Etihad. And we designed together, bringing the competence and the know-how into the UAE, a product that is 3D printed as a part for an airplane, which is airplane certified. So one of the first concrete examples where we're bringing 3D printing in additive manufacturing into the UAE, a great example and furthers to follow. All in all, digitalization is a topic that does not only touch industrial environments, but certainly all aspects of diversifying the UAE. It's the infrastructure buildup, it's the industrialization and security and standard of living, so all areas around buildings, sea, rail and air, which can be connected to, for example, a MindSphere operating system to analyze the data and optimize operations, to optimize also the workflow in mid and downstream industries and in energy-intense industries. That's about efficiency, which is a major topic, and big data analytics can help there. And in any case, the whole digitalization of enterprises that I've been talking about applies to lots of industries, and therefore I think it's an important statement by the CEO, Qatar Mobility Innovation Center, to say that at the heart of the future of innovations in Qatar and the region will be the transition from the traditional internet to the Internet of Things. That's why we donated or set aside 100 million by Jokesa last night in order to donate licenses for Siemens software and industrial software. Large part of that you've seen in my presentation just now for 5 universities in the UAE, because one thing is very important, that we take our employees along and that we get everyone fit for digitalization, which is the opportunity for the future. And we're looking forward to digitalization and co-creation, which are a key to sustainable growth. And let's team up together in order to make this going, in order to reap the benefits of this kind of gigantic opportunity. Thank you very much.
Thank you very much indeed. Welcome to the new world of making things. We're very tight on time, but I've got to ask you one more question. What does this do for engineers and designers when they have tools like this and when they can do this kind of thing in a factory?
It is something that we see, we use this in our own environment very, very strongly, and we're pushing digitalization and have been doing this for almost 20 years with remarkable results. And what we're seeing is that people really go for it because it's so much more interesting in terms of the working environment that they have. there's so much more that you can achieve in a short period of time in terms of leapfrogging and getting better technologies in place. It's a fascinating field, and we see that a lot of people are really coming along and are willing to embrace this.
That's terrific. Ladies and gentlemen, thank you very much again.